My name is Akshay Mehta and I'm the Systems and Applications Engineer in the Simple Switcher product line at Texas Instruments. Today we'll be talking about compensation made simple using the LM460X and the 460X family of devices. We'll be looking at LM46002 in particular with the demonstration. The LM460X and the LM460X are the new wide V and fully synchronous regulators capable of handling 36 volts and 60 volts at the max input voltage. They work on the current mode control principle, and the internal compensation is tailored for a wide output voltage range of 1 volt to 28 volts with a switching frequency range of 200 kHz to 2.2 MHz. This makes the selection of inductor and output capacitor fairly simple. Let us look at the differences between current mode control and voltage mode control. In a current mode control, the comparing ramp is generated by looking at the ripple current flowing through the inductor, whereas in voltage mode control, the internal comparing ramp is a fixed voltage. Because of the way the current mode control works, there are two real poles that need to be compensated, whereas in a voltage mode control, there are complex double poles that need to be compensated. This makes the integration of the compensation in a current mode control very easy, whereas integration of compensation in a voltage mode control is fairly complicated. This here is a typical schematic of LM46002. The LM46002 can work with a variety of output capacitor chemistries, but if you have only ceramic capacitors at the output, and if you have a very stringent requirement on the output voltage deviation during a fast load transient, then it's helpful to add a feed-forward capacitor in parallel with the upper feedback resistor. Optimization of feed-forward capacitor can be done using this equation, and to learn more about this equation, please refer to the application note SNBA 718. Now let's look over the demonstration about what we just talked. This is the evaluation board for the LM46002, and this is the LM46002 IC. I'm using about 150 microfarads of ceramic capacitors at the output. This is the low transient circuit, and for now I have removed the CFF capacitor from the circuit. The rheostat is going to give me 200 milliamps on the steady DC load. This here is the input power supply. It has been set to 24 volts. DMM1 is going to be used to monitor Vout. It is reading 3.3 volts. DMM2 is used to monitor the steady DC load. It is reading 200 milliamps. The function generator is going to be used to create a low transient from 200 milliamps to 2 amps. The oscilloscope is going to be used to monitor the current through the inductor and the output voltage. So for now, let's see what the low transient of 200 milliamps to 2 amps will get us. I'm going to turn on the function generator. And as you can see now, the inductor current is pulsing from 200 milliamps to 2 amps, and the output voltage responds to the low transient with a few rings. This as such is a stable response, but if a more cleaner waveform is required, then adding a feed-forward capacitor is usually helpful. So let's go over adding a feed-forward capacitor. I'm going to power down the input power supply and turn off the function generator, and we'll solder the feed-forward capacitor onto the circuit. So I have put down the CFF capacitor on the circuit. From the equation described before, a standard value of 47 picofarads was used for CFF. Now let's go ahead and restart our power supply and see how it behaves. So I'm going to turn up the voltage on the power supply to 24 volts. And I'm going to turn the function generator on to give me a transition from 200 milliamps to 2 amps. As you can see, addition of about 47 picofarads of CFF on this circuit greatly helps optimizing the design. The overshoots and undershoots are well below 200 millivolts and there is no ringing on the output voltage. Therefore, in conclusion, the LM436OX and the 460OX family of devices are very easy to use with internal compensation and can be easily optimized by adding just one component, the feed-forward capacitor. For more information, please visit simpleswitcher.com, and thank you for watching.